morning. Hi, I'm Anika.
I'm Elise.
And I'm Layla.
And we are DIVISO.
So our main goal of our project is that we plan to reduce the amount of polyethylene terephthalate plastics, or PET plastics in general, as they're the most widely produced and used plastics in the world. And we also want to do this to transition into the emerging world of biodegradable and reusable products. And to do this, we created a structure called DIVISO that will do that for us.
So our structure will utilize an enzyme that is able to break down the PET plastic into its two monomers, and our structure is artistic, so it will be able to maybe help spread awareness and support the cause, and will allow people to interact with it.
So the topic of our entire project is creating a more sustainable environment to limit PET waste overall. 6.5 million tons of PET waste is dumped into landfills per year, and we need to eliminate that in order to create a better place and a better environment. So we created a machine in order to break down this PET plastic.
So first, what are PET plastics? PET plastics are a type of clear, lightweight, and strong plastics, and they are widely used for packaging foods and beverages. But even though they are recyclable, if they're not recycled, they take a very long time to degrade.
So this enzyme called PETase is found in the bacteria Ideonella sakaiensis and will break down the PET into MHET, which is further broken down into the monomers ethylene glycol and terephthalic acid.
So the technology behind this plastic degradation of PET is through the PETase enzyme and applying different catalysts through hydrolysis. So using different catalysts such as esterases, liposases, and ketonases are previously been reported to exhibit PET degradation activity. So while applying the catalyst as well as PETase, they will both undergo the hydrolysis in our main tank in order to create the two monomers.
So who here has ever thrown away a plastic water bottle into the trash can? Yeah. So this is where the problem lies. So if the plastics are not recycled, they enter a degradation process, but while they degrade, it takes about 450 years to actually fully degrade. But during this, they break down into these tiny microplastics, and these microplastics will find their way into the environment to harm life as they absorb toxic materials. And as you can see in the graph here, even though recycling was introduced in the 1970s, most plastics are still not recycled.
So another aspect that influenced our decision to make this project was the emergence of biodegradable and reusable products and the rising popularity of things such as metal boba straws and hydro flasks.
So we decided to create a machine that undergoes the hydrolysis activity, and we wanted to degrade the PET. So we used a bacteria called Ideonella sakaiensis, which is known for degrading plastic. There's a specific enzyme, PETase, that actually helps do this. So when we decided to do this, we wanted to have an actual contemporary art piece that could show and interact with people. Hence, we used works from Joyce Westrop and Frank Gregory in order to create more of a contemporary art piece that shows how this PET is then degraded into these two monomers.
So we are proposing to create these divisos to place around public areas for the public to use. And the basic process of these structures are that once plastic is put in, the structure will grind it up, and enzymes and catalysts will enter to break down the PET into two products, ethylene glycol and terephthalic acid. And since ethylene glycol is a liquid and terephthalic acid is a solid at room temperature, we can separate those two, and they're very useful for car companies and computer companies, so we can earn some extra money by selling them. And this is because ethylene glycol is a component to making automobile fluids like coolants, and terephthalic acid can be used as a component for cleansing products.
So this is our 3D visualization of the model. As you can see, these are the two grinders in which you put the plastic inside, and this will make it into more microplastics, in which then the main chamber, the green little thing over there, is where the active hydrolysis goes on, where the catalyst as well as the PET-ACE is then inputted. This will then degrade slowly into this little box over here, which stores the ethylene glycol and the terephthalic acid. The ethylene glycol The ethylene glycol is mixed, is the precipitate, so it will stay on the little contemporary art piece that we have inside, and the terephthalic acid will go into the little chamber. And we have a 3D visualization model here. So we decided to create this as an interactive art piece, so we can see how people can actually put in their water bottles and see how it goes through the entire process. And yeah, that's the 3D model.
So we hope that our structure will help slowly diminish PET plastics, and hopefully they'll fully disappear by the year 2039, which is 20 years, which is not a lot of time if you think about it. And then in the meantime, we can limit the production of PET and slowly switch to biodegradable materials. So in conclusion, we hope that by creating DIVISO, we can give society a fun and interactive way to help the environment with every piece of plastic that is disposed.
So while DIVISO is an artwork, we hope to expand it to the industrial scale, because the main function is to reduce the amount of PET plastics as we transition into a more eco-friendly world.
So while creating this project, we got some different ideas that posed questions, such as how do we restrict PET from continuing to be manufactured?
And another question we encountered was, how could we separate PET plastics from the landfills and recycling plants so we can further reduce the amount of PET plastics in the world?
And finally, we wonder if we can expand this to other plastics such as PVC, PE, and styrofoam.
Thank you for listening, and here is an AR model that you guys can scan with your phone so you can see it in real life and move it around and stuff, so that could be cool if you want to do that.
Thank you.